Hey, nice to meet you all. I'm David Tuhy, Vice President and General Manager of the SSD version of Optane, the data center SSD version. And the reason we do both the persistent memory and the SSD version of Optane is because our customers want to use it for traditional storage applications too, where it's a 4K block interface, and they want things like dual port, active-active failover. They want to have it in hyper-converged infrastructure. I think Enrique was asking about that earlier. And so, we have both versions, right? And they're both highly valued by our customers. And Frank showed these two charts earlier. I think the one that a lot of people know is as you go up a CPU core count growth, obviously you need to feed it more memory because we're virtualizing more actions on the CPU core count. And our CPU core count is going to go up dramatically. It's already gone up a lot in the last 5 years. It's going to go up dramatically over the next 5 to 10 years, and per socket, per CPU. And that drives more needs for memory, and it drives more needs for storage. A lot of our cloud customers like Amazon, they actually specify a specific SLA of how much IOPS per gigabyte, in their case it's like 50, 16K IOPS per gigabyte, that each virtual CPU gets, and they meet that commitment as part of their SLA when you pay for their storage. So as you increase the CPU core count, you increase the number of 50 gigabyte chunks you have to deliver. That means you have to increase the storage too. The other thing that's going on is that's demand. On the supply side, Frank always shows this on a logarithmic chart because he's a super geek. But I'm showing you a linear version of that same problem, and it's very, very simple. Our NAND SSDs have topped out. The NAND media itself is getting bigger and more bits per cell, which is great for cost, but it's making it slower, especially on writes. So if you do something very active, like 30% read, 70%, 30% write, 70% read, a 70-30 workload, which is a typical workload for HPC, big data analytics, databases, machine learning, a lot of these cool new workloads do a lot of data manipulation. Our NAND SSDs are actually getting exponentially slower over time. And that's creating this gap that Frank talks about where the Optane SSD can help. And so what we announced is today, that's embargo has been lifted, is the second generation Optane SSD. This is a grounds up redesign. It's a brand new ASIC, brand new firmware architecture, brand new second generation media. That is now capable of supporting both PCI Gen 3 and Gen 4. And we call it the P5800X. That's the public name. The code name was Alderstream. Our engineers have been working very hard, taking all the learnings they've had from the very first version of our Optane SSD, the P4800X, which was called Coldstream, and just poured their hearts out to get this to be the world-class SSD. And we're talking about it as the world's fastest data center SSD, and we have several benchmarks that we think can substantiate that claim. The specs are on the left. It's basically running maxed out line rate, whatever you can do on a PCI Express Gen 4 architecture for sequential reads, what you could do for 4K IOPS. It's about 1.5 million. 4K IOPS is what you can do. But what's more important is it's almost full line rate writes too. And so it's literally the first SSD that can take advantage of both ends of the PCI Express communication bus, which turns out to be bidirectional. So you can do a full line read and a full line write on that same bus at the same time. It's got amazing latency. It's 6 microseconds under what we call 99% loading. But if you really, really hammer it hard, if you're doing Black Friday sales, you're trying to close the quarter, you're trying to compute a transaction, even under super, super heavy load, which we call 99.999 or 5 nines, it's still 25 microseconds, which is orders of magnitude better than our best DAN. We've also have a new mode in this device. It's got 512 byte reads. So a lot of our customers want to use Optane as a metadata manipulation engine or a key value manipulation engine. So they like these smaller reads. And so we built that natively into the drive. And so you can see it's 4.6 million of these 512 bytes versus 1.5 million 4K. And that's an amazing new feature and a lot more endurance. And so what I'm comparing on the right over here is this is the gen over gen improvements of Optane versus Optane, comparing our first generation SSD to our second generation SSD. So it's 3x faster random read, 40% better quality service, 3x faster sequential writes, 67% higher endurance. And that's just comparing Optane to Optane. If I compared it against NAND, which I'll show you in some other charts, it's stunningly better. Right? I think I showed this in the video, maybe you guys saw it, but we just showed basically the 4 major ways our customers tend to value our SSDs is either through low latency, better quality of service, which means no jitter, better IOPS, which means better hot data caching, or better endurance. And so, we show some proof points here. Aerospike, the world record that's on the website right now is 1.4 million IOPS. Pretty soon it'll say 2 million IOPS because we'll post our stuff out there. But Aerospike's a very popular database as well. With high performance computing and with the financial services industry, it's a very high performance, great transactions per second database. And they have this benchmarking tool called their ACT tool, their certification tool. We did 2 million transactions per second versus our best in class, which is 480K of our brand new NAND SSD. And the other thing that's really important about this is this thing called zero failures. And so a failure in this case is any transaction that has a longer than 1 millisecond response time. So you still complete the transaction, you fulfill it, but you take longer than a millisecond, which violates a lot of the SLAs that people want to maintain for these high transaction per second services. And so not only does it hit 2 million, but it has zero failures. There's never a time that it takes more than a millisecond to respond to a transaction request. And that's money. That's especially when you're looking at things on the right, like financial services, fraud detection, compliance, ad delivery, bid requests. The faster you get insights, the faster you can make a decision and provide the data to your customers you can beat your competitors, right? And so we know latency really matters. And this SSD is, world-class, best SSD out there for this problem. We also talk about quality of service. We do spend a lot of time on our NAND SSDs working very hard to get the jitter to be as low as possible. But you can see the ranges. All those little blue dots are our measuring of our P5500 D7, our NAND SSD. And you can see how it varies. And it's not anything about the SSD itself. It's just as the nature of NAND. We arrange it in large pages. That's what makes it so cheap. And every once in a while, you have to do some data collection. You have to reformat. You have to do garbage collection. You have to relay out the blocks for lifetime, and that creates this very stochastic behavior. But on the very, very bottom, you probably have a hard time even seeing it. There's a little light blue line, and that's the new second generation P5800X. And basically, on this chart, you really can't even see it jitter relative to the NAND. And so it's 66% better. And we know that's important because a lot of our customers are like the dual port customers, EMCs, PowerMax, Hitachi, IBM. They charge their customers specifically on this vector. So you have to pay a lot more to have great quality of service because they know that matters to their customers. It's a value vector that end user will pay for to have this type of super responsiveness under load. Don't vary under load. And then IOPS, this is the other one we talked about, but what we're showing you on this chart, the dark blue line is our new 5600 NAND SSD, the D7. It's Gen 3, Gen 4 capable, new architecture, and it starts out at about 1 million IOPS, and then you can see as you go across, you start doing what we call reads writes. So this is 80% read writes, 60%, 60-40 read writes, 40-60, all the way just to 100% write, 0% read. And it's just a phenomenon of NAND SSDs. As you start putting a lot of pressure on them, they fall down on their IOPS because they're trying to maintain your performance and also maintain data integrity and all this balancing on the drive. Whereas Optane, because of we built the cross-point architecture, we really have no issues relative to data landing and data maintenance. So basically, we do something I've never seen before as an engineer. Is we actually are able to go above the theoretical maximum of performance, which is 1.5 terabytes or 1.5 million IOPS, so it's 1500 K IOPS, because we're able to take advantage of both channels of the PCI Express bus and deliver even higher performance, which is just stunning, right? When I first saw this chart, I was really surprised. And now, as an engineer, you go, well, you can actually get both sides of the channel, so it makes sense. But you can see it actually starts going down towards the end there, and that's just purely because we're only taking advantage of the right channel of the PCI Express Gen 4 bus. What that means, though, is how does that matter to our customers is there's a lot of applications coming out. We have a whole class on this where the cloud customers, especially when they look at scale, when they first started going and they had multi-core CPUs, they started adding a SATA SSD in there to offload their network bandwidth, and they did 1 gig Ethernet. They did a 10 gig Ethernet, they did a SATA SSD, and they did a multi-core CPU, and that let them put more VMs per server, which was in the end justified all that extra cost. They had fewer servers delivering more VMs per server. Now, as we moved forward, we added more cores to the CPU roadmap. Our customers needed to have more I/O, so they went to an NVMe SSD, and then they added 25 gig Ethernet. So now we have 24 core CPUs and are going up beyond that. 2 sockets of 24 core CPUs. We've got hyper-threading, which means it looks like there's 98 total VMs, and it's going to go up. So now they're all looking at moving to optical networking and getting what is that next click of performance capability to be able to absorb that. And what we're showing you on this chart on the right is how an Optane SSD, would compare to be able to build a elastic block cloud and a disaggregated networking stack, a storage stack using optical networking. And this is where we're starting to see a lot of people get very interested in Optane. Is for an SSD, they want to use it as a write buffer or a write cache in front of lower, cheaper capacity NAND, especially being able to take advantage of Optane to move from TLC NAND, 3 bits per cell, to 4 bits per cell. Because when you go from 3 to 4, you save significant money. And so they're using a little bit of Optane as a write buffer to front end a capacity tier NAND. And you can see the comparison here. If you want to do 100% reads, it takes 2 Optane drives versus 4. 100% write takes 3 versus 13. But there's also another vector in here that a lot of people are beginning to understand, which is the smallest NAND drive we make is about this one here in this generation is about 3.2 terabytes, and they're going up. As we go up to more layers and more bits, it's the making of a smaller drive in NAND is harder. So what that means is if you need 13 drives to handle all your writes, you have to at a minimum buy 41 terabytes, 41,600 gigabytes of NAND drives just to handle that usage model, which is a lot more than a lot of customers need. We have customers looking at 2 Optane drives to handle their write buffer traffic. So you have to, even though Optane drives are a lot more expensive than a NAND drive, from a bit efficiency point of view, you're paying a lot less to have it solve these particular usage models because you're just putting a lot less. You only put the bits you need. We call that efficiency. So it's a data efficiency thing. Fewer drive count and fewer bit count to solve the problem. And so these Optane drives are 16 to 35% more efficient. And last but not least is just the ecosystem. We show this chart all the time. Intel prides itself on working with all our key customers. We sell, we're a building block supplier. These are our customers. They're precious to us, and we work deeply with them. We work with cloud service providers on software, and of course, we work with the software industry. And for the SSD version of Optane, we have a significant software industry that already does 4K block storage. We can just plug into it. We do find that we have to tweak it sometimes. We have to go in there and actually change how they did the architecture or change how they did some driver work just to optimize. But what's really exciting in my mind is some of this new software layers that are being created to specifically take advantage of this stunning capability, the latency capability of Optane. So Jan's Oxbow, which is the maintainer for the Linux stack for storage, is driving a new thing called IOU ring. And it's basically taking all the kernel task switches out and taking a pulled mode version of IO so that your VM can ask for a data set, pull it straight out of the IOU ring without having to do a single kernel switch, because the Optane SSD is so fast, you don't need to park it. You don't need to put yourself on the shelf like you do with hard drives. You can get the data and keep going. Celero is one of the leading companies. They just plugged Optane in, just plugged up an Optane in just to see what it looked like, and it ran faster. Vast, maybe you guys have heard them. They're the one that built the whole Optane plus QLC architecture from scratch. It's very media aware. We asked them just to run a quick test on putting the P5800X into their existing system, and that system still runs on PCIe Gen 3, so it's not even a Gen 4 system. And it's already they said it's already 20% faster writes. Just taking a P5800 and running it in a legacy system is 20% faster. And then we're doing lots of innovations. So we just announced a joint lab with Nutanix. We're continuing to go forward because even though these hyperconverged infrastructure is one of the areas we have a lot of wins. So VMware, vSAN, Cisco HyperFlex, Nutanix, these hyperconverged companies, which are usually used in smaller instances, have significant value they've derived from using Optane. Right, and so it's a case study of a small business taking advantage of Optane versus a huge company, and we pretty much are doing really well with all the hyperconverged infrastructure companies, either edge or they're small, and so bottom line is there's a whole bunch of new software coming specifically anchored on how to extract the value of this super low latency, super high performance Optane SSD and PMEM, of course.
So just curious, how much faster? I don't know. How much faster than the bus is that SSD? So like to what degree do we have a Ferrari that, is sitting on a 405 freeway?
No, so we balance so we architected the ASIC and all the media throughput to be exactly balanced to that bus. So the bus can run 1.5, and we built the SSD architecture to run saturation on 1.5. So we didn't overshoot it. For example, if you want to go to PCI Express Gen 5, we will have to build a different product to go into optimize that bus. So we built the whole engine to be optimized to the Gen 4 bus, right? What is interesting about that, though, is because Optane has the ability to run almost full line rate reads, I mean, it does run full line rate reads, but almost full line writes, you get this thing you wouldn't normally see, which is that bump over the curve. And so it's balanced. We balanced the whole design to PCI Express Gen 4, right?
So a practical question, we get these, I love that we have Intel on because you guys sponsor all kind of interesting content on YouTube, and we get these guys who build these storage arrays with Intel Optane memory, and they always run into these weird bottlenecks that we don't see. But from a practical experience, because I've run this into the enterprise, we see these raw numbers from the SSD, but then we get this storage layer inside of the OS that prevent us from actually using these drives to the best of their capabilities. So talk to us about the use cases for when I take these things and put them inside of a generic bare metal system versus where I'll have to look to a Nutanix or a VAST or an EMC to optimize for the speed of these disks. I'm sorry, of these SSDs.
Yeah, it's really good. It's just like, show me what an end user gets out of this, right? I'll give you the example on Cisco HyperFlex. They run VMware as their virtualization engine, but they have their own storage stack, right? They have a unique storage stack to HyperFlex. Are you still with me, Keith? Okay, I thought you turned off. I thought you just lost. But anyway, so we worked with them on optimizing their storage stack to take a unique advantage of Optane drive. They actually have a very interesting little software layer we helped architect with them that lets them to bypass all of the VMware hypervisor and talk straight to the drive, their storage stack. They have direct access to it, right? And this is shipping. This isn't theoretical. This has been in the market for over a year. So we sat down with them and we were trying to go through a case study. And so we found out that the Dodgers, which believe it or not, the Dodgers is a small business. You think of the Dodgers as this worldwide global brand, but there's like less than 2,000 employees all in the Dodgers. And I think it's less than 500. Don't quote me on that. I'll get the numbers for you. But and so they had like 30 old servers, classic UCS, disaggregated service order, and they refreshed all that with like 6 of these nodes, these hyper-converged Cisco nodes. And what's fascinating about it is the usage models they do with it. They run their beer service on there. They run ticketing on there. They run the video conferencing on there. They run Wi-Fi on there. They do all of their algorithm stuff on there when they're looking at security and facial detection. So this thing is like goes from being really boring, frankly, to when a baseball game actually happens, when COVID gets out of the way, to being super busy, right? Just goes stunningly busy. You could just imagine 50,000 Dodger fans can't get into the stadium, right? Because the ticketing won't work. That's not a good outcome, right? And so what they found is that their peak workloads were just so much better out of this thing because Optane could take all that pressure. And the other thing they found out, and this is one of the quotes they talked about, is when they ran their analytics, the joke I was talking with the CIO is one of the people we have on our videos, Ralph Escobar. He's really hilarious, a good, smart, super smart guy. He said that the algorithm guys called him up all the time and kept claiming that it was crashing because it used to take them like 13 hours to run these algorithms, and they were running less than an hour, right? And so there's a simple case study of a simple small business running with an Optane simple system, just running virtual machines and getting a big benefit across their infrastructure, right? I'm not sure if that's what you're looking for, but I think that's one example.
No, I think I love the example, and I think
I can give you more.
The question was more towards a practical, which is, people take something like a generic Windows storage platform and try to create a vast storage data array. There's this kind of missing concept of the value that your customers bring towards Optane. I think you just laid out a great example of that. of the ability to bypass. And VMware has fetched a rather fast or low latency storage overhead, but even the ability to bypass that in the UCS example is a great example of the value that your OEM partners are bringing to Optane when they take Optane and build special class systems to be consumed by end users.
Yeah, just to sort of follow on from what Keith was saying, a lot of it sounds like there's a lot of work required from Intel's partners to actually package this into their systems to bake it in so that you have to have the right PCI Express version, you have to have some software optimizations required to actually drive it well. So again, for me as an enterprise buyer of this, if I'm working in enterprise architecture and defining, okay, what is my standard server buy going to be for this particular workload that I tell all of my solution architects, this is what you will use. How far advanced are you into that in terms of like qualifying the product with the server vendors, having standard build, so I know what the bill of materials looks like, so that I can throw that onto my enterprise purchase plan, tell everyone and say, right, this is what we're designing on for the next, whatever it is, 3 years on my refresh cycle?
It's a really good question. So, and I think I'll answer for the SSD, and I think it's probably also true for PMM, which is, so we're on catalog for all of the big OEMs that you'd ever care about, HP, Inspur, Lenovo, Huawei. We're pretty much on catalog for everybody on the price sheet. In addition, we've done a lot of solutions integration because a lot of those customers are moving towards selling solutions as an appliance. So Cisco HyperFlex, for example, Dell VxRail, HP solutions. And so not only we got it on catalog as a generic line item, we've actually got it on catalog in their solutions bundles, right? So you can just order it. And then we built separately. We built with people like VMware and just a lot of ISVs, these kind of like kit packages so that people could just go, okay, hey, if I was looking at that, what would I get? And so we have a whole what we call solutions architecture document. And a lot of this is on Intel.com. I don't know, I think there's over 30 of them up there that can just say, hey, if I was interested in doing something with banking on VMware vSAN, what would be my benefit, right? Or healthcare, right? What would be my benefit? And so, that takes a lot of effort. It's mostly communication. It's actually, once we built the core architecture and get it right for one software stack, it usually pretty much just works. But the effort is around tuning it to every end user's kind of mindset and needs. We do a lot of solutions work for that with our customers. I don't know if Kristie, if you got anything else to add.
The answer is almost exactly the same for PMM. The one thing I would say is we also take the step to do to make sure the certifications are done with the OEM solutions, so that you don't have to go worry about getting SAP HANA certs or separate VMware certs. So it's very much a solutions-based selling motion as in these early years. And so we, for example, if you're looking for VDI, we have the test results, the recommended configs, the settings. And it's all available for the customer to go look at. And every major OEM and now even the channel partners have gone through the training and the processes to make sure that they're also capable of recommending the right solutions.
I can't help.
Go ahead.
I can't help but notice the complexity that's starting to arise from all of this. One, you guys are doing great work with like UCS, VMware, and Dell VxRail. That's great from a pure, how do I get the most IO in this kind of packaged solution? But to Justin's point, as the enterprise, and maybe this is, kind of a philosophy where you guys would like to kind of help us understand where Intel is going with this big picture. Because as I think about how difficult it is to eke out all the performance necessary from PMM and Optane SSDs, now we're getting into kind of your 6 pillars, and we're talking about interconnects, we're talking about security, we're talking about Xeon Ice Lake processors with 4th gen PCI. How should end customers be looking at how to consume the Intel of the future? Because I this isn't me taking a bin of parts anymore and putting it together and throwing Windows on it. How should I be considered about partnering with your OEMs and Intel?
Yeah,
It's exactly what you just said. We have to take a solutions approach, and we try to do our best to build our own reference version of it and go work with all these key partners to get them to be able to do the same thing we're doing, right? And so, yeah, when we're working on Hadoop or we're working on Spark, we're in there working with them on the CPU. We're working with on the networking. Sometimes it's an FPGA. Sometimes it's certainly an Optane component from our point of view. And then we work with them on the software integration, and then usually in the end, the good news is there's a bunch of smart companies out there that are on that list that's their core business, and so it's really just about getting the first one right, and then learning how to scale it. And the way our customers consume it, the very first thing everybody's got to ask you is, show me this saves me money, right? Show me the TCO benefit of this thing. When we go into an enterprise, we better walk in and say, here's how you're going to buy 4 servers instead of 6, or you're going to buy less whatever of this capability because we're getting you better density, better scale. So it always starts with TCO, and then we just show them. Okay, once you get them convinced they'll save money, then they want to know how. Show me how you're going to save money.
And if I can add a little bit of perspective, Keith, your perspective is just spot on, right? Customers are trying to figure out how to navigate this complexity. And this complexity, we often come to you as Intel with a bag of parts, and we say, oh, we have this great hardware solution. We have this great hardware solution, and we're going to show you how to do it, but you could do it 1,000 different ways, right? And I think the one thing that is the guiding principles is that as Intel looks at these 6 technology pillars, memory and storage is just one of them. And we have to get ourselves aligned from the beginning of our architecture development and really be that trusted advisor of how all these pieces fit together and how we make it easy. So I would say that, 2/3 of our job at Intel is actually really about bringing the ecosystem along so that it's easy. And I use the example of building cache levels into the CPU or FPGA accelerators to do, typical compute. As these things change, right now they're new concepts. They're very confusing. It's hard to know how to navigate. Over time, it will become just the accepted standard. And now everyone comes to expect, tiered storage architectures. That didn't used to be the way that we did it. So I think we just have to day by day come back to the fundamentals of what are those 6 pillars of technology that we develop, and then how do we as Intel bring that portfolio together into full integrated solutions that just work. It's a big task.
The way I see this technically, it's funny, when we launched SSDs, we actually found that when we put them in people's PCs, they had a problem. The virus scanner had counted on slow storage, and it started running so fast because the NAND-based SSD replied quickly that it used the whole CPU. And so you're not worried about that now, are you? Because the software has been tuned for that, and that's not happening on your SSD anymore. So this is a big change. Optane is, we haven't introduced a new memory since the 80s. And so it's a real opportunity for people to build systems on top of both Optane SSDs and Optane PMEM that are just fundamentally better than the things that came before them. And the leaders will go do that. And then everybody else will follow. And so
I love that you mentioned that, because one of the things that just kind of been eating in the back of my mind during this presentation is that Intel, as you look at the 6 pillars, is starting to become more opinionated about what a distributed system should look like and how it should perform and how it should consume. You guys in the past have left that up to kind of the market at large, but I think for good reasons. You need to step out and say, hey, Deos is a great example. Deos is an example of how you would implement PMEM and SSD storage together to provide a fast object store. Where do you guys see yourselves as in that evolving relationship with your OEM partners as you become more, I can't think of a better word than opinionated as to how the distributed system should work in these 6 different pillars?
I think things like One API, you see us starting to deliver more software pieces. I think Deos is a great example of, hey, here's an example of how to do distributed storage really well. It's not the only way you might want to do it. You might want to do it other ways, but it's an example of it done really well. So that kind of example leadership, I think, is important. And I'm proud that Intel does that.
Mm-hmm.
Yeah, I mean, I would add, too, that our relationship with the OEMs, I've noticed it changing over the last couple of years. And the fact that they now have quote solutions catalogs, and that we're jointly defining our solutions roadmaps together, shows that we are, as opinionated is actually a good word, as we see the benefits and where we see things going. They're actually partnering with us to extend those into offerings that they have. Much more collaborative.
Yeah, I think in my mind, it's also a spectrum. When you go everything from open source, I think we're very heavily influencing open source. When you go to work with someone like a Dell PowerMax or Oracle, they have a really strong architecture base, and they have some really good ideas how they do it. And then what we often bring to them is the tricks that we see. We see the world coming up from the device. They see the world coming down from the app. And there's some unique things you have available to you when you're looking at it from the device up. We bring in some unique insights to them, but we rely heavily on them to be able to bring the architecture. Right.
I have a question about OEMs. So you mentioned OEMs, but actually you work both with OEMs and cloud providers, and I mean the big names. How is the relationship different? I mean, these guys want to manage the entire stack most of the time, and they need something that is designed for their very specific need. While
you talk about cloud service providers, Enrico?
Yes.
Okay.
While the OEMs, yes, I mean you work with them, but they design products for the rest of us. So the kind of problematics that they have are totally different at the end of the day. So how can you manage? Okay, Optane is very flexible, for example, but actually form factors and everything is totally different, and maybe APIs. And so do you have different teams? Do you have different way to approaching this? Or, once you build the base technology, the things on top are almost the same? I mean,
I think we might have different answers. So David, do you want to answer it for the SSD side, and then I can talk about what we do on persistent memory?
Yeah, so the fundamental benefit we have with the SSD version is it's a 4K block NVMe device, right? So in general, it will just plug into their existing storage stack. So the tuning that we do is stuff like I showed you on that 100 gig optical, where we show them how to use it a write buffer. So we do tons of open source code. I personally have code at Tencent and Alibaba and at Twitter and and this is code that we've written, open source code, and we've given them to help implement solutions. And some of them are huge wins. I mean, the Twitter re-architecture we did with them on their Hadoop cluster, we took their server core count down by 4x, right? The density they got was enormous. Now, they bought a great CPU, they bought a great SSD, I'm going to be a NAND SSD back then, and they bought networking, they bought up our stack, but they saved a huge amount of money. And so they're all super smart, and they're all super capable. Believe me, they hire hundreds of engineers. But again, we have a benefit that we're coming at it from our little technology view up, and it turns out there's some things we know too, right? And I think that's where we get the symbiotic relationship with cloud. And I agree with you, though. They have a very strong opinion on how they want to architect their stuff. But I think we can bring people like Frank Hady to the table, and they think of them as peers. They think of them as friends. They think of them as trying to solve the same problems, and it's very collaborative.
And I would just say that on the persistent memory side, because it's in the compute infrastructure portion of things, we're very custom design oriented. So for everything that we do with the cloud service providers, you may never even hear about the projects that we work on. And it can be, jointly defining the features, the modes, and how things operate, to even building full solutions with other components in the infrastructure or, custom items. So we don't just say, okay, here's your DIMM, go have fun. It's definitely a collaborative engagement over multiple years.
Yeah, when I have these discussions with CSPs, it's the same actually, whether it's persistent memory or an Optane SSD. It's understanding what workload they have, and sometimes it's their own code that's running and they're offering a service, and sometimes it's an instance. But it's understanding what that is, what those bottlenecks are, and then how Optane can improve memory capacity, increase memory capacity, or decrease storage overhead, make it faster, and then how that turns into either a better experience for their customers or a lower TCO, so they can offer a lower cost to their customers. And so we actually get in and work with them at a systems level to understand what the bottlenecks are and how we can address them. And I forget who, but somebody mentioned the 6 pillars. That's the beautiful thing is we talk to them about the memory and storage pillar, but we also talk to them about the other pillars too. And so we can really have that systems platform level discussion with them, hardware and software, and figure out how to help them. And then they do the rest because now we've worked together and they know where to take the technology.